Welcome to our course, Live Interaction for Aircraft Propulsion. So, I am Vinayak Kulkarni from Mechanical Engineering IIT Guwahati, and I am the instructor for this course, Aircraft Propulsion. This course basically was more about the propulsion system of aircrafts. So, for that sake, we started initially with the governing cycle for the aircraft engine, which is Brayton cycle. So in the Brayton cycle, we initially understood what are the processes of Brayton cycle and what is the performance of Brayton cycle, like what are the performance parameters of Brayton cycle. Therein we understood efficiency, work ratio, kind of, or turbine power output, net output, these kind of the performance parameters of Brayton cycle. Then we went ahead and discussed about the different attachments for the improvement of performance of Brayton cycle. Those attachments included multiple compressors, one of the attachment, and then other multiple combustions we were trying upon. And then that way we were trying upon multiple turbines. So reheat, regeneration kind of things were thought for affecting the performance of the Brayton cycle. And then we evaluated the efficiency work ratio for the Brayton cycle with these attachments. So this was the initial part where we considered Brayton cycle with ideal processes. As one of the questions it was posed that how can we understand the cycle is ideal or real when we are given with an example. In the example, whenever we are dealing with ideal cycle, we are assuming that the efficiency of any attachment like compressor, turbine, or any component like compressor, turbine, or heat exchanger, then these efficiencies or effectivenesses are 100% in case of ideal condition. So if efficiency is not 100%, then we are working with real cycle, wherein we would be provided with the actual efficiency numbers of turbines and compressors, or combustion efficiency or effectiveness of the heat exchanger. So whenever we are given with non-100% efficiencies or effectivenesses, then we are working with real conditions. So this is the answer for the question which was posed. Then, having said or understood about the working cycle of the aircraft engine, then we went ahead and discussed about different aircraft engines. And the engines what we studied included turbojet, turbofan, turboprop kind of engines. Plus, we also studied what is the working principle of scramjet, ramjet kind of engines as well. So here we worked with the thrust of the engine and power output of the engine. So there, important difference between the cycle and the engine was that in the case of engine, net work output will be 0, since the turbine would produce the amount of work which is required to run the compressor or overcome the transmission efficiencies. So then rest of the enthalpy will be expanded in the nozzle, and then we will get the thrust. So in that case, we also studied what do we mean by nozzle, what is choking of the nozzle, and how to obtain thrust from a nozzle. So this was what we have studied in the course of aircraft propulsion, which there onwards goes towards the individual components like compressors and turbines. So if you have any questions and queries, please pose. The important point what is getting learned in the second phase of the course is that there are different types of compressors, there are different types of turbines, and then there are velocity diagrams for the turbines and compressors. So from the velocity diagrams, we can find out the work input for the compressor and work output for the turbine, which otherwise we could have found out from the thermodynamic relations when we were working with the cycle. So when we were working with the cycle, we were making use of enthalpies for finding out work interaction. But when we are studying the individual components, we have learned that how to use the velocities to find out work out or work interaction. With understanding about the compressors, we saw that compressors are mainly of two types. One is axial, another is centrifugal compressor, and then they will have different types of interactions with the fluids which is entering into the compressor. Main work of the compressor is to compress the incoming air to the desired pressure ratio. So within that, the rotor interacts with the air and then it evolves a velocity triangle at the inlet and at the outlet. From these velocity triangles, we can eventually find out the work interaction. So in case of axial compressor, we will have inlet and outlet of the airflow, which will be always axial. But in case of centrifugal compressor, we will have axial inlet and radial outlet. If you have any questions or queries related to this part, whatever it is getting taught, please mention in the chat box so that it will help me to answer the questions. Beyond the interaction with chat box, we are always interacting with the students in the portal, where students' questions are answered on the portal regarding the tutorials or regarding the videos. Similarly, when we were studying for the turbines, turbines are also of two types. One is axial turbine and other is radial turbine. So the flow pattern would be similar. In case of axial turbine, flow would axially come into the turbine and axially leave the turbine. And in case of centrifugal or in case of radial turbine, flow in at the inlet flow will have radial velocity and then at the exit it will have axial velocity. So this was what the types of turbines what we are studying. Important concept what we studied when we were working with the turbines or compressor was there are turbines kind like impulse turbine and reaction turbine. So which is governed by the important parameter, which is called as degree of reaction. So we have to know what is the degree of reaction. So in case of turbines, we have static blades and moving blades. Static blades act as nozzle or guide vanes, and moving blades actually convert the kinetic energy into torque or power. So what is the amount of enthalpy drop which is happening in case of the moving blade when the fluid is flowing? About the total enthalpy drop which is happening in one stage. So that ratio was titled as the degree of reaction. In case of gas turbines or gas turbine engines, we have mostly reaction kind of turbines where degree of reaction will be more than 0. If you have any questions, please type into the chat box. This will help me to understand the question and answer the same. So if you have no questions and queries, we will stop here for the interaction session. But we are anyway interacting onto the portal. Please be active on the portal so that it will help us to communicate with you and resolve your queries. Thank you.